It's a good evening or good morning, wherever you might be. Welcome to Orlando.NET User Group, July 1st, 2021 meeting with Jason Bock. We'll be talking about source generators for fun and maybe even profit. That sounds interesting. This meeting is being recorded, so if you do not consent to the recording, this might be a good time to exit. And the rules for this meeting, pretty simple. Stay on mute when not talking or when not asking questions. There should be, in most client windows, there should be some kind of reaction toolbar, and you can raise your hand if you have a question, and we'll try to buzz you in for questions. This meeting is run by the organizers of the Orlando.NET User Group and Orlando Code Camp. And that's the current board. And these are where you can find us. So on the web at onetech.net. The best place to find us is on meetup.com/onetech or on Twitter at onetech. Upcoming meetings, we have Chris Woodruff, who also works with Jason. He'll be talking about developing great web APIs architectures with ASP.NET 5. On July 27th, Sean Kalin will be talking about Acromodel and Akka.NET. And on August 12th, Siva Kumar will be talking about GitOps. We don't have a sponsor for this month, but if you'd like to sponsor, get in touch with us. Or if you would like to contribute, you can do that from the Meetup page. Is there open floor for announcements? If you have any projects, any events, or any job listings, feel free to come off mute and announce at this point. Do we have any announcements? All right, I guess we'll move on. Today's agenda, the meeting is recorded and will be available on YouTube. We'll post the link after the meeting at some point. And Jason will be talking about source generators for fun and maybe profit. Jason is a dev advocate with Rocket Mortgage and a Microsoft MVP. Oh, fellow Mike, I used to be a Microsoft MVP, so always good to see one. Jason has over 25 years experience on biz apps and a wide variety of frameworks and languages. He's the author of the .NET development using compiler API, metaprogramming in .NET, and applied .NET attributes. Jason runs Twin Cities Code Camp, which hopefully he'll be able to do one soon, and I can go to Minnesota. I've never been there, so I'd love to go there. And you have an electrical engineering degree from Marquette. Okay, cool. And that's the email address for Jason. So with that, I will hand over the floor to Jason, and I will go on mute and allow Jason to do his thing.
All right. Thank you for the introduction. One quick question is, how long should I be targeting for time?
So it's about 7:08. You can go on for 75 minutes, 90 minutes.
Okay. Yeah, I'd probably be a little bit less than that, but I just want to make sure I didn't go over a typical time. So, okay, cool. All right, so I'm going to share my screen and get the presentation going. So again, that introduction pretty much explained everything I'm going to be talking about tonight and who I am. So a little bit of personal information about myself. If you want to, check out Twitter or GitHub or YouTube, I have some stuff there, so feel free to check that out. If you have any questions during the presentation, I'm going to go one step further and say, feel free to come off of mute and just interrupt me and say, hey, I got a question. I'm going to be watching the chat on my side screen here, which is why I'm looking down here at times. So I'm going to be watching that throughout the presentation and hopefully catch some questions. But the in-person experience is so much better. I wish I would have been actually able to fly down there and be in Orlando, where it's the same temperature as Minnesota right now. and enjoy the same exact weather. But you know, it's nice to actually be in a room with everybody else and get that interaction with other people, and you know, be able to answer any questions that you have, which may be the same questions that other people are having. So if you just want to type it in the chat, that's fine. But again, if you want to come off of mute and just interrupt me, I don't care if I'm talking or not. Just feel free. Hey, wait, Jason, I got a question, and I'd be more than happy to answer it during the presentation. If something comes up later, you can send me an email at jason.r.bock@outlook.com, and I can answer it offline that way. So it looks like a bunch of downloads for the demos that I'm going to be doing today. The first one is what I'm going to be using to drive how some of the source generators I've created and how they work. The inline mapping one, I'm going to go through in a little bit more detail to show you the setup and how source generators are actually written. The other two are what I'm going to be demoing, but I'm not going to be going through that source code in detail. It gets pretty deep in some of them, especially the rocks one. So that one, if you want to, feel free to take a look at the repository and dive into that code. But that's what those first 4 links are. The last one is where I have my presentations, so you can download this presentation there. And I'd highly recommend that you do that, because in the notes section for each slide, I usually have references to things that are related to that particular slide. But in the last slide in the notes section, I have a bunch of references there. So that can be a great source to take a look at things and dive in deeper later if you want to. Okay. You move that off the screen. All right. So what I'm going to be talking about tonight, if PowerPoint would let me move forward, there we go. So I'm going to spend a little bit of time on the what and the why of source generators and why I'm excited to talk about this. I've done this talk, I've kind of lost count this year already, or over the last 12 months, but I enjoy talking about it. It's one of the coolest features I've seen in C# for a while, and that's why I'm excited to share it with people here and answer specific questions that people have. So I'm going to go through the what and the why. Most of this talk is going to be demos and going through code and explaining how this stuff works. And then at the end, I'll give you a little bit of a call to action and where you can go from here. All right. So first, the what and the why. Specifically, what are source generators? What are these things that were introduced into C#9? Or to be a little bit more specific, it's .NET 5. Okay. So this is a feature, and I want to state this because it's good to know this up front, is that this is something that will only work within .NET 5 and beyond. And now that C# is tied a new version to a new version of the .NET runtime or the release of .NET, it's C#9. So this is something that will not work if you're on C#8 or .NET Framework 4.7.2. Okay, so this is only .NET 5 and beyond. You can generate, the code generation itself, what you actually generate is completely up to you. You could generate things that are only for a particular feature back in some particular version of C#. But you need to be on .NET 5 for this to work, okay? So what are source generators? When I was in college, I didn't work at a factory that produced cars, but I would work in the summers at the place where my dad was a salesperson. And as mentioned before, I got my degrees in electrical engineering. So I wanted to actually work in the engineering department just to get some experience over the summers. But the first 2, I had to work in their factory, which is fine. Got to make some money, which is good. And they made air compressors there. So I got some hands-on experience on what it's like to take apart, move it over here, tap the hole, move it over there, drill in some keyhole here, and do that for about 8 hours straight a day, which is a little mind-numbing, to say the least. But that's the analogy I want you to keep in mind when we talk about source generators, is you're taking this raw material, or you're taking bits and pieces of information from various sources, and you're going to assemble them in some way such that you're going to create a product out the other end, just like what you see here with the cars. Specifically, you're going to be looking at code that currently exists in your application, and your factory is going to produce new code on the other side. One other thing to stress here is when I say new code, I mean completely new code. You're not going to be able to edit code that currently exists. So one of the books that I've read in the past, which is called Metaprogramming in .NET, is a topic that's near and dear to my heart. But this isn't full metaprogramming. You can't look at a piece of code and say, I want to remove this method invocation, or I want to add this method into this class, or anything like that. You can sort of fake it if you use partial types. So if you don't know what a partial type is, it was a feature that was actually introduced in the C#1, but frankly, I never used it that much at all. Your experience may vary, but it was something that just never came up. But now with source code generation, you can have a class that currently exists as a partial class and add a whole bunch of new members to it in a different partial class, because then the compiler takes all those and puts them together at compilation time. But you can't change code that currently exists. That's not allowed with source generators. And when I've watched interviews from the people on the Microsoft team, they've been pretty adamant to say that source generators probably, they never say never, but probably won't ever have that capability in the future. Okay. Now, don't let that deter you, because it's still a very powerful feature, and I hope to persuade you on that as I go through the demos. One thing I should also mention is that these factories, these source generators, are just classes. At the end of the day, it's a class that you write that has access to your source code and creates new code out the other end. So you can look at other things other than just code. You can look at additional files. That's something that you can set up in your project and say, I have an additional file like a JSON file or a text file, whatever it may be, and you can have access to that file, use it to create some new code. You can, if you want, you can go off to a database or a service and look for information there. Keep in mind, though, that this is part of the compilation process. So you want to be a little bit cognizant in terms of performance. You don't want to have a source generator that's going to take 20 seconds to generate the code. Because if somebody runs .NET Build or CSC and includes your generator as part of the compilation process, then that's just going to happen as part of that execution. But if you're using a tool like Visual Studio, these generators are going to run when code changes. How exactly that works is a little bit undefined. I haven't been able to, if somebody knows of a document, I would be really interested to hear that. But they definitely will fire more than once before you would actually hit, in my case, F6, which says compile the whole solution. So again, be very cognizant about speed and performance, because you don't want your user to have to sit there and wait for a long time for your source generator to generate all that new code. Okay. So that's essentially what is a source generator. But why is this so important? Why is this something that, again, I find so fascinating and so interesting and so empowering as a developer? There's essentially two reasons why I'm fallen in love with this feature. The first one is performance. I believe that every developer has the intention, whether or not they actually execute this, but they have every intention to write code that's going to execute fast, that their users are going to be delighted with the performance. They're going to want to come back to ask for more features. They're happy with how quick everything is and how snappy everything is. I don't think a developer is purposely putting in sleep invocations on the thread for 5 seconds every time they call a method. That would be very malicious, and we wouldn't want to do that. So I think every developer wants to write fast code. We're not always successful. I know that it's very easy to write something to realize that it doesn't scale as you get more users, or if things are executed more than you expected, or you're getting a bigger data input. But there's other places in code that if you're using something like reflection, that, and I have to say this with a little bit of air quotes here, it can add to performance in terms of making things act a little bit slower. Again, this is something that I always stress whenever you're talking about performance. You have to measure this. And if you've never used a tool like benchmark.net, I highly recommend looking up that tool, starting to investigate it. I'm not going to talk about, well, I am going to mention it quickly, but I'm not going to go into details about how it works. That's a whole presentation, if not many presentations in and of itself, but it's a great tool to get really good benchmark numbers on your code. Okay. So in any event, if you're writing code that is using reflection, you may end up hitting a little bit of a performance penalty because of the dynamic runtime nature of reflection. It's fairly optimized, but it still has to do things at runtime to determine, does this type have a method, or does, whatever it is that you're looking for at runtime, and then do the appropriate thing and make sure that it works. The nice thing about source generators is you can take code that's written that's using reflection, and that's a candidate to look at and say, maybe if instead of waiting at runtime to figure out what this code is going to do, emit that code as C# code at compile time, because that will probably, and I can't make a guarantee here, but that will probably be faster than what you can do with reflection. And I'll demonstrate this with an object mapping example that I've created. Okay, so that's performance. The other one goes back to that idea of working in a factory and the assembly line, because it's boring, it's repetitive, it's monotonous. There are lots of things that I bet you can think about as a software developer that you say, I know I have to do this in code, and it's not hard to do, but it's tedium. It's something that I just don't want to keep doing all the time, but I have to do it. And if I don't do it right, things aren't going to work the way I expect them to. If you can create a source generator to algorithmically create that code for you, then that's one less thing that you have to think about. And then you can go off and start solving new problems, or like GitHub Copilot, just write everything for you these days. That, maybe we're getting into that world in a very short time span. I don't know. But again, the nice thing with source generators is you can take that code that you can easily repeat and make it such that a developer doesn't have to write it themselves. So let me give you a couple of quick examples on both these points. The first one deals with INotifyPropertyChanged, which, if you've never heard of what this interface is, it's essentially the standard interface that you use to state if the state of an object has changed, specifically if a property value has changed. Okay. So there's this interface, INotifyPropertyChanged, where if you look at the code here, you can see if my name property changes on the setter, I'm going to call this method I've created, notifyPropertyChanged, which uses caller member name attribute, which is really nice because that's a little trick that you'll get to see who's actually called you. So in this case, it will automatically be passed in with name. And then I'll invoke that event to tell anybody that's listening that my property has now changed. Okay. This isn't hard. I mean, in the grand scheme of things, as things we do as a developer in .NET, and specifically C#, this isn't something that is that difficult, but it's that monotonous, repetitive thing that you have to do over and over again. And wouldn't it be nice if you could write it in a much simpler way? In fact, this was, from what I've heard, the baseline for the C# team in implementing this feature, in that they had to come up with a way to solve this problem. There's probably many different ways to do this, but they needed a way to show source generators could make this simpler. And so what they did, and this you can find in the references in the notes section that I have on the last slide, they came up with a whole bunch of examples, this being one of them. Okay. So the way that they solve this is they say, well, first you need to make your class a partial class, because what we're going to do is essentially create all this code for you as another partial class. And so again, the compiler is just going to put all that together. You take your field and you put this auto notify attribute on it. And the source generator is going to look for that on a field and say, I'll generate all the rest of the code for you. Okay. And everything is good. Everything is grand. So if you see this compared to what you saw before, this is much, much easier to reason about. And you can go off and do something else by just typing in one line of code on a field. Okay. What about performance? So say you wanted to do something with that way, object mapping. Okay. There is a lot of good libraries out there that have millions of downloads on NuGet, and we'll talk about one of those later, that do all sorts of amazing things with object mapping. And my intent in talking about this is not to, put that tool down or that package down or any of them in any way. It's just to illustrate the point that if you want to make something that is generic, and I don't necessarily mean generics in .NET, but code that is generic that can work against anything that you throw against it, you've typically had to solve it using reflection. This is just one way that you could think about saying, if I have a source object and I have a destination object, how would I find the properties between those two that essentially have the same types and the same names, and that they're accessible? Because if they are, then I want to be able to say, take that source property value and set it to the destination property value. Okay. This will work and this is fine. But again, this has that hit of reflection. Whereas if I just wrote the code this way, where I have a source object and a destination object, this is about as fast as you can make it. Yeah. And this is, if you wrote it by hand, you'd probably write something like this. Yeah. Why don't I just source generate this? Why don't I just make this so that it's part of your compilation and you get that reduction in speed in a good way? Yeah. So again, that's what we're going to be looking at this example in more detail in the demo. Yeah. Now I've been talking about generating source code. And when you generate the code in the source generator, at the end of the day, you're basically just going to be creating C#. And there's multiple ways to do this. You could just do it all in strings, have your C# code embedded in strings and concatenate them all together. There is a NuGet package called Scribian, which is kind of like a templating tool that you can use to make your code generation a little easier. You could actually use stuff from the compiler API to generate a whole syntax tree for you if you'd like. And I mentioned that third option specifically because no matter how you generate the code, you're still using and looking at things that are in the compiler API or Project Roslyn. Yeah, that's the compiler that has been around since 2015, where you're compiling C# with C#. And there's this whole API surface that you can use to examine your code and build new code. Okay. This is not trivial. Again, it's not something that's going to take a substantial amount of time to learn, but building anything that uses a compiler API, source generators, analyzers, code fixes, refactorings, if you're not familiar with it, it's going to take some time to kind of get your head around how this all works because it's quite vast. And my degrees, I never went as a comp sci major. I never had a class in compilers or anything like that. So it's been a little bit of an adventure for me since I've been watching Project Roslyn ever since I heard about it. But even though it does take a little bit of time to get familiar with how everything works, not just with source generators, but with the compiler API, I think that investment is worth it. I think that's where the profit aspect comes into play. Because not only are you going to be able to start looking at your code and thinking about how can I make things faster or how can I minimize the repetitiveness of what we're doing in our code, but you can start using that tool in different ways in different areas to reduce the time it takes to write code in some other place or to do some analysis on your code and find bugs quicker. So that's where the profit angle comes into play, is that you might be able to start making some gains on the reduction in time from what a developer has to write or what the code has to execute at runtime. Okay. So let's get into some demos, which is where most of this talk is going to be. So let me get that up here, and I want to make sure that I have this over here, just in case anybody's putting something in the chat. And again, when I said that I've done this talk before, this may be because of my dynamic, wonderful speaking style. I don't know, but I usually don't get a lot of questions. I think in part because this material isn't beginner. This can feel a little bit advanced at times, and that's okay. So if something doesn't make sense, I have all the time in the world tonight. I'm not going to make everybody stay for 2-3 hours, but I have time. That's what I'm here for. So if I talk about something and you're like, I don't quite get what you're talking about, let me know, and I'd be happy to dive into it a little bit more detail. Okay. So the first example I'm going to show is a way to do object mapping between two objects. And this package is called inline mapping. All these packages are NuGet, so you can reference them if you'd like that way. That's actually how I'm referencing them in this demo project. So the idea is I have a class called source, and the name doesn't matter. I'm just literally calling them source and destination to make them a little explicit. But I have this class that has a couple properties on it that I'm going to set. I'm going to print them out to the command line. And then I've got this map to destination method, which you've already seen how it's implemented in the slide, but I'm not going to dive into it just yet. Yeah, it's an extension method that's generated for a type source. And what comes out the other end is if I hover over this, let me zoom in here real quick. Okay. If I hover over this, you'll see that it's of type destination. Okay. And then I'm going to print out those values. So if I run this and get the console window popping up and zoom in on it a little bit, you'll see that I have the source here and the destination, except you have that comma there because there's something that's not being printed at the end. And that is this reason property. The reason why is that if I go to the definitions of these classes, you'll see that ID, name, and when match on both the source and the destination, but reason doesn't. There's no value on source to match to it, so it never gets set. Okay. Now notice that there is an attribute on source called map2, and I'm passing in the type of destination. So in my inline mapping NuGet package, there are actually 3 attributes you can use. You can either say map to a source to a destination. You can have a map from a source to the destination, and that's where you put the map from on. Or you can have an assembly level attribute that just says map, and then you pass in the types for the source and the destination. I'm mostly going to just focus on map 2 because I don't want to go through all 3 explicitly, but they all end up basically doing the same thing at the end of the day. Okay. But this is what my source generator is looking for. I'm trying to look for any places that a type has a map2 attribute on it. And if it does, what is the type of the destination? And then start basically doing mapping between the two to find out which properties I can retrieve and set, and then actually generate that C# code. Okay. So to build a source generator, let me actually go into this project first. Okay. So this is all the code for inline mapping, and I have some test projects and things like that. I should mention, even though I'm not going to go into the tests, you can definitely test source generators. It's a little tricky. I'll come back to what the trickiness is in a moment, but you can do it. I am a huge believer in writing tests against your code. So you can do it with source generators. And if you're interested in the details, take a look at the repository and you'll see how that all works. But the main project here is inline mapping. And the thing I want to point out in the CS project file here, because there's a whole bunch of stuff here for NuGet packaging and whatnot, but it's the target framework. You must target .NET Standard 2.0. And if you say why, I'm going to say because Microsoft told you to. So I just do that as a matter of convention for source generator projects. Okay. You'll also want to reference these 2 projects at the very least, because this lets you actually do all the things that you need to do with source generators and related compiler API types. All right. Okay. So you'll set up a project that way. Then you're going to define a class like I have here with map generator that implements iSourceGenerator. And it also is attributed with the generator attribute. Okay. That's pretty much it. And on iSourceGenerator, if I go to definition on that, you'll see that there are 2 methods that you can implement: execute and initialize. Well, that you have to implement. Execute is required. That's where you're actually going to be, you're going to be creating and adding your source code here. Initialize, you technically don't have to do anything, but I've always implemented it because it helps you look for things. It's I think of it as a filter. You'll see what I mean in just a second. Yeah. But this is what you need to start with your generator. So question, what is the difference between, gotta get my mouse over there. What is the difference between mapping and casting? And just on me, mapping is copying identical attributes regardless of type. Yeah, I'm not really sure what you mean here. I mean, with object mapping, I'm just taking two types that don't have any inheritance relationship between the two. I'm just looking to see if what structurally maps between two properties on both the source and the destination. Yeah, casting is only one object. I want to cast A to a type of B or something like that, like Rob just said. Okay, so that's what I mean by those two. All right, so you have your generator, and I'll come down here. We'll get to execute in a moment. Initialize here is where you can basically say, hey, I'm looking for certain things in my code. In my case, for example, I'm looking for classes that have the map2 attribute on them. Okay. So what you can do is you can say, I want to register for syntax notifications. Again, keep in mind, you're going to be working with syntax trees that have syntax nodes and syntax tokens and all this other stuff that completely makes up your code. In fact, I'm going to pop this tool up over here called Syntax Visualizer. And I would highly recommend, if you're using Visual Studio, that you install the Compiler API SDK or something, Compiler Platform SDK. That's a thing you actually have to pick on the Visual Studio installer. So that will give you some templates for analyzers and refactorings, but it will also install the Syntax Visualizer tool. And this I've found so useful whenever I'm trying to reason about what my code is doing and what are the actual types in the tree. I mean, you can see here, there's a literal tree of nodes and tokens and everything else. If I click on my class here, you'll see that switched over to here to say, well, you just clicked on an identifier token. That's part of a class declaration. And if I click on that, then all of the class actually gets highlighted on the right. So this is really nice because you can just say, hey, I want to do this. And I want to look for this in the source generator. Well, what are the things that I need to be concerned about from a tree perspective? You can just literally type out the code in an editor, look at the syntax visualizer and see what those things are. Okay, so keep that tool in mind. It's very, very useful for this type of stuff. Okay. Do source generators work in VS Code? Yes. So good question, because I want to make sure that this is explicit, that this is a .NET 5 thing. This is not tool specific. So even though I'm using Visual Studio, this would work with VS Code or it would work with Rider. That doesn't matter. You could do this from .NET Build or CSC. That would work perfectly fine. Okay, so the syntax visualizer stuff that I just showed you, that's a Visual Studio specific tool. I believe there's something similar for VS Code and potentially Rider, but I'm not sure about that. Okay, but the source generator stuff is tool agnostic. Okay. All right. So in this register for syntax notifications, what you're going to be doing is creating another class that you'll pass into this action. And that's what's actually going to be used to let you know, hey, what are the things that exist in the tree and what do you want to look for? So in this case, my receiver implements this iSyntax context receiver. You can actually also implement iSyntax receiver, which is fine. But I found this interface also gives you something called a semantic model. As you can see down here in the one method you have to implement. That semantic model, you can kind of think of, it's not reflection, but it starts feeling a little bit closer to that, in that you get better information about your tree. As you saw before in the syntax visualizer, I was seeing I got a class definition syntax or an identifier name or all this other stuff that it's great, specifies everything, but I want to know more information about what the type is, what's its base type, what are its members, what are those types of things, okay? And when you get a semantic model, you can start to go through the tree in a semantic way and start asking questions that are a little bit easier to answer, okay? So that's why I'm implementing this interface, okay? Did you say .NET 5 or C# 5? .NET 5. Not C# 5. It's much newer than that. Okay. Yeah. Okay. So on visit syntax node, what I'm going to look for is the thing that the compiler is telling you that it's currently looking at, is it a type declaration syntax? So is it a class, is it a struct, or is it a record? Okay. If it is, then I'm going to basically look to see, do you have a map from or map to attribute defined on the class? How many there are, I don't care, but are they there? Okay. And then I'm going to actually get the symbol from the semantic model. And then I'm going to look through all of the attributes on that type symbol. Okay. And if any of them equal or are exactly the same as map to or map from, then what this line of code does is it basically just says, okay, on this type, you have this attribute that says you want to map from that type to this type. That's essentially what that code's doing. So the receiver allows me to grab all the things that currently exist in code and package them all up into this one property down, I'm sorry, above here, what I'm calling targets. And that's just what I need and what I, for my specific example here. Okay. So that's what the receiver is for. In execute, you can look at the context that you're given and look at the syntax context receiver. And it is, if it's of that map receiver type, then now I'm responsible for saying, if I want to, I can add new source code by calling add source. I can also report diagnostics. So on that error list in Visual Studio, where it will tell you you didn't put a semicolon or anything like that, you can also create diagnostics of your own to tell the user certain things that you ran into that they currently have in their code that don't match or meet your requirements for your source generator. And then you can report those as diagnostics, actually make them as errors. And then the user has to go back and look at what they did and say, maybe I need to fix stuff. Okay. Now, again, how you generate your code is completely up to you. The way I'm doing it here is I have this method generate mappings. Okay. And again, I'm not going to go through all this line by line. I'm just going to kind of just go through this at a little bit higher level. But what I'm going to first do is look through all those pairs, all those things I found in the receiver. Okay. And I'm going to use this mapping information class that I created that's going to kind of validate all those things. And what I want to have come out at the end is what you see here are these maps. This is a way for me to say what properties and their types, what mapped between the two, because that's what I want to put in my source generated code. Okay. So while I'm doing this, you'll see I have some diagnostics.add here because I want to add some diagnostics to basically say maybe you duplicated one of those attributes and you don't need to do that. If I can't access a constructor on the destination, then I'm going to report that as well, because then I can't generate code that would actually be able to create a new instance of that destination type. Okay. So that's what I'm kind of looking for here. As you can see, I'm getting all the destination properties and trying to map those to source properties. And if you start squinting at this line down here, you'll see that I'm getting C# code in a string. Okay. These are all the maps between a source and a destination property. Okay. I'm going to put these all in this property maps thing. And so what comes out the end of this work in my generator is telling me, okay, now what things do I need to actually create C# code for? And that's what I'm going to do in my mapping builder here. Okay. So in my mapping builder, I end up calling build. And again, start squinting a little bit. You can start to see some C# code coming in here. You can actually, if you have an editor config or other things set up to configure styles, you can look at that as you're seeing here and be able to say, well, do they like tabs or spaces? And then you could honor what they want for their style, or you can just do the right thing and use tabs. So, by the way, I'm just trying to get a fight going here, because tabs versus spaces is such a great argument to have. But you can do that. You can actually look at how things are configured and, make that generated code look a little nicer. And which is nice if you're actually authoring a source generator rather than just putting it all in one big long string. It'd be easier to look at it as something that's a little bit easier formatted. Okay. Now also notice I'm using this indented text writer. This is from the code DOM namespace of all things, but it's nice because I'm able to actually indent and outdent rather easily in a stream. Okay. Again, however you want to write the code yourself or build it, completely up to you. This is just another technique, and I've kind of landed on this one because I find it easy for me, right? So I'll determine if I need namespaces. If I do, you can start seeing, oh, there's some code I'm going to be generating for a namespace and a curly brace, and I'm going to indent. So, based on what I need to do, I'm going to put that code in there as needed. I can also, one thing I can do too is say, if that source type was not a value type, what I'm going to want to do is actually put in that is null check on the source that's passed into the extension method. Okay. So yeah, now everybody's talking. I'm sorry. I've completely sidetracked the chat because everybody's talking about tabs. So, you can generate that code. If it was a value type, I wouldn't need to do a null check. But if it's not, then I do. Okay. So if I come back up here to building the type, this is where you're going to see more things like the static class that I'm going to need for that extension method I'm going to put in there. I'm looking at all the constructors from that destination type that are accessible. And so I can generate multiple extension methods to say, either I'm going to have no arguments, or I can actually put the arguments in the extension method. You can pass them in, and they'll be passed into the destination object when you create it. Again, you have all this power available to you when you're generating your code. This map extensions method here, you can see here is where I'm going to be defining that first property of or that first parameter of an extension method. Here's where the extension method is going to be declared. Here's that check for is value type. We're going to be looking for null. And then remember all those maps that I talked about before? Down here is where I'm going to be putting those maps in my code so that the source and destination properties will be set as expected. Okay. So again, everything that comes out of all this stuff is hopefully some new code that doesn't have any diagnostics and is now part of my project. Now, when I say part of my project, I want to be a little bit clear here. If I jump back to my demo project here, and I go into dependencies, analyzers, and my mappings, if you look over here, you'll see that I actually have the CS file here, but that's not saved to disk. Okay. Source generators by default are not actually saved to disk, though, as you're going to see in a moment with debugging, you can actually debug into them, and it's kind of a cool, slick feature, but it's just because it's C# code. It's just part of your project. If you use a tool like ILSpy, you could look at your resultant assembly and you'll see all that generated code in there. Okay, so pretty cool. Yeah, the spitting cobra. So I heard about that this morning. I was like, wow, yeah, there's a spitting cobra on the loose. So you can see these in Visual Studio, but they're not actually saved to disk. There is a flag that you can put in your CS proj file to say I want to do it, but I've personally not had a reason or a need to myself. Take a look at my notes again. You'll find what the switch is, but I've found it's actually kind of a pain to have all that stuff, because then it may be accidentally part of your Git commits, and it may change a lot, and it can get kind of noisy. So I'd only use it if I'm really trying to debug stuff. Yeah. But anyway, that's where the code is. If you want to click on it, you can see it, or you can just, if I come back up here, just do my F12, and that's what the code is. And you see at the top, there's that yellow bar that says it's auto-generated, can't be edited. Okay. And that's the thing too, when you generate source code, you can't have a generator rely upon another one running before it. There is no ordering to generators. You just have to basically say, I'm going to look at this and I'm going to run. And you never are looking at generated code. You're only looking at code that is authored by the user writing it. So you can't generate code based on generated code. Okay. So is the last comma valid code? I'm assuming you mean the one after when here. And yes, that is valid. And actually that's a nice trick that you can use if you don't want to be so neat and think about the last thing, does it need a comma or not? The fact that you can do this is a little bit messy, in my opinion. I wouldn't write the code myself this way, but generating it, that I don't have to have extra code in there to say, am I on the last map and do I have to remember to put a comma at the end or not? Okay, but this does compile and it does work. What if I have different opinions in mapping? Example, self is null, null, new. Then Well, the way I wrote this is you're going to get an exception. You can write, you can generate code here that would say, you know what, in that case, here it's going to return null. And then I could have destination have, the nullable annotation on it with the question mark and return that. If that's what you want to do, that's fine. If I want to change inline mapping such that there's a configuration setting somewhere that I'm going to read where somebody says, instead of throwing an exception, just return me a null, then I would change the source generated code to do that. Again, you're flexible in terms of how you actually generate that source code. Okay. And you can also be very opinionated, like I am saying here, you can do this, but to Rob, you can go to my repo and put in an issue and say, hey, why don't you do that? Let people have that option. And I can put that in the tool. Okay. Now, since this is source generated and part of your project, if I put a breakpoint here and say run under the debugger, when I get to the breakpoint here and I say step into F11, you step right into the source code. Because again, C#, if you've used tools like Fody to do a whole bunch of IL weaving in your code base, or even something like PostSharp, especially IL stuff, that becomes really hard to see what actually changed and how do you debug it, and it can get to be quite messy. Whereas with this technique, it's so easy because it's just that language that you use on a day-to-day basis. Okay. Now, what the generator generates may end up looking a little bit messy and doesn't match to your style per se, but it's all C# code at the end. And as you see down here in the locals, I can see what the self is, and I can see what the ID value is and the when and everything else like that. Okay. So yeah, it only sees what the original is and not the result of other generators. And they're pretty adamant about that on the C# team. They don't want to add in something that says, we want to put dependencies in between generators. They're not ruling it out, but they keep getting asked that, and they're like, it's a much harder problem if you start allowing that to happen. So they're pretty, they're kind of like, yeah, we've thought about this, and we're not going to be doing it right now. Okay, but you can debug your code, which is cool. If actually, I'm going to go back. I already have this here. I'm going to pin this or put it over here just to illustrate a point. If I come back down here and I take this reason property and I put it back up in source, you'll see that in near real time, of course, now it's not going to do it because it's a demo. And this is the first time this has actually not happened. Oh, that's interesting. It's actually trying to save the file. Okay. Let me try this again, because this has always worked. And there are recordings on the internet of me doing this talk before, so I know that this actually has happened before. So let's give this another whirl. Say reason and put that back up there. There you go. Okay, that worked. Okay, so you see that now we actually have that other property mapped in there. If I come back up here and take that off, it eventually goes away. Is it real time or near real time? Yeah, exactly when that gets executed again, I don't have an exact answer. But as you can see, it does get executed. And when you would build, it absolutely, your source generator is going to get executed. Okay. So what if source has the property and destination doesn't? So if I take this off and I put it up here, nothing's going to happen because there's no match between the two. Okay. But again, what I'm doing in my tool with this package may not be what somebody else wants to do with mapping. So don't get too, these questions are good. I don't want to stop questions, but don't get too hung up on, is it doing this particular feature or this particular action or not? Because the point of this demo is to say, this is what you can do with a source generator. This is what you can put together. And if you'll say, well, does it do this? Then I could potentially add it in. I want to be really clear. I'm not trying to create a whole new object mapping tool that people can use with millions of downloads. There's already stuff out there like that. But this is more for illustrative purposes on how these things kind of work. Yeah. So, all right. So, and I know you're Rob, so no worries. Go back to the project. I do want to make sure that I point this out, that again, you can have a test project and you can write your tests against the generator and see, did you get the source text that you expected and everything else. It is a little tedious if I show one quick example, in that if I want to say map receiver tests, and I want to say if I'm passing in this code, that I actually get things within the generated code that I expect, but I want this to actually just kind of run like what you saw in my demo. And so what you can do is you can create a project like this, where I'm going to basically write tests that end up having that code generated, and then I'm just going to see, did the generated code work the way I expected to. If you do this, you have to reference the project with this output item type property on it, okay? And that's actually going to load the project as though it actually contains analyzers or generators in our case. So then they'll execute like a generator would, which is great. But if you change your project, specifically the generator, to fix a bug or add something else, and then you recompile, it doesn't show up here. You have to shut Visual Studio down and start it up again. Once it makes that reference to this project, it basically binds to that version until you unload it. And that's just the way it works. So I found that the best way to test these is to kind of write unit tests and to make sure that a change actually is working the way I expect it to. But then I'll eventually shut down and start up again, and then run the integration tests as well. It's a little klutzy. I will not deny that, but that's just kind of the way it works right now. Can I package my source generator in NuGet? Absolutely, you can. All three of these examples that I'm talking about, you can find in NuGet. You can reference them in your project. They'll reference as a source generator, and off you go. In fact, I would highly recommend that you do that, because that's a fairly simplistic, very easy way to get your code out and being referenced by other people. Is just make it a NuGet package, and that will work. And if you want to see how all the CSproj settings and everything else, take a look at the CSproj file from this, and you can see some of the things I've got set up to make it a NuGet package. I talked about performance. So I said, what happens if I would create a benchmark.net project that would compare my inline mapping tool compared to reflection, the way I showed you before, and then against this tool called AutoMapper, which, again, a lot of people have used, know what that is. And I said, what would be the difference in performance? I'm not going to run it here because running benchmark.net can take a little bit of time. But if you run this, what would be the difference in speed and memory consumption? Keep in mind that AutoMapper has a lot of users. It's a highly optimized package, but as far as I know, it hasn't used source generators just yet, okay? I think there are actually some other NuGet packages that do. But if I looked at the results of all these, this is what I got, okay? So if you look at my inline approach, it's the fastest of all three, and it allocates the least amount of memory, okay? AutoMapper is pretty good, but it's an order of magnitude slower, and it allocates a little bit more memory. Using reflection is the worst, and that's not unexpected. Now, could AutoMapper be updated to use source generators? Absolutely. And if it is, I'd be highly interested to see if these numbers change and get close to or identical to what I'm doing here with this package. Okay, so that's the gains you can make from using source generators. Let me go back to my demos project. I'm just going to show you a couple more things that I've written with source generators. Are there recommended best practices and use case scenarios for source generators? Again, it's those 2 points that I made before. If you have a lot of reflection code in your project that's potentially a target to use source generators, so that that code is actually generated and compiled, you may get a performance increase. If you want to get rid of repetitive code, or there's some other things you might want to do. I'll talk about some other ideas at the end of my presentation. Okay, but those two are the things I would look for. Is if you can say, every time we have to build this thing, we got to do X, Y, and Z. Why don't you have a source code generator do that for you? And then that'd be a potential candidate to look at. Okay. In terms of best practices, just write your generator as fast as you can. In terms of making it work, just there's really no, like, in terms of best practice that I can think of. Yeah, it's like I said, once you get into that execute method, how you get to adding your source code is up to you. And then it's really, how do I create the strings efficiently or things like that. Okay. All right, let me go into the second example here, and that is doing partial function application. Okay. So if you've used a language like Python, I think F# has this, Pony, which is another language I've looked at. It's kind of an experimental language, but kind of cool. So I would definitely check it out if you're a language geek. Pony. They have this idea of partially applied functions. And what partially applied functions are is, think about when you call a method in C#. If you're going to call a method that takes two arguments, you're always passing in 2 arguments. Forget about optional values and everything like that for a moment. You're typically passing in those values and you get a result. That's when you're fully applying the function. You're giving all of the values that the method needs, and it's going to give you a result. What about, I need to call a function that I know I'm always going to pass in the first value as being this value. And so if your language supports partially applied functions, what you can do is create a new function that essentially hard codes that first value or the first n values. And then you can specify the rest of them if you'd like. Okay. Now in C#, you can kind of do this mostly with funcs and actions. If you look this up on the internet, you'll see people that have kind of implemented something like this before. But the problem with func and action, there's one minor one and then one that's a little bit more. Funcs and actions can only take 16 parameters. If you have a function that takes 70 parameters, you've got more problems than that you can't express it as a func or an action. Okay, so don't do that. But then you can't use one of these generic delegates. And for the most part, they're going to work for anything you've ever written, if you've written code that I would consider to be reasonable. But another thing is default values or optional things in a method. You can't express that with a func or an action. If you would write a delegate by hand, then you can. Well, why don't I have a source generator do that for me? Okay. And there's some other things you can do if you don't limit yourself to funcs and actions, and also just even generics. There are some things that you can't pass into a generic, like pointer types, that a source generator can get around if you're creative enough. Okay. So in the case of partially applied, what I did is write something that says, hey, let's actually do this partial function application. So let's say I've got a method here called adds on a class called maths to differentiate it from math. Takes 2 ints and returns an int. Pretty simple. We also have an add optionals where we have 3 parameters that also have default values. Okay. That's a static class. Notice here that I also have a class called functions where I have a multiply that takes 2 ints and returns an int and does a multiply. Okay. Well, let's come back up here. And you see if I pass in math.add as a function to partially apply, and I say my first value is always going to be 3. So I'm always going to be incrementing by 3. And that's what I'm going to print out here when I add 4 to 3. But then I want to do that for functions here as well. So I create a new instance of that and partially apply to multiply a value of 3. And so I'm going to triple whatever I pass in here. So I should get 12 on this one. But what about the optionals one here, where I want to say I'm always going to have 3 as my first value, but then whatever the function is that comes out, maybe I don't pass in anything. Maybe I pass in a 10. Maybe I pass in a 10 and a 20. And if I run this and look at the resulting console window that I will kill there, you'll notice that 3 plus 4 is 7, 4 times 3 is 12, and then these will vary based on what I'm actually passing in or not. So how does this work? Let me go into one of these methods. And you're going to see here, first of all, I create an apply method that generates the first parameter as being a func that takes 2 integers and returns an integer. Partially applies the first value, and it's going to return a func of 1 int coming in and an int being returned. Okay. I'm going to create a new func of an int and an int, passing in the second value to whatever the function is that was given to me here. And I'm going to use what C# already does for me in closing over values, with this value being always passed into that new method. Okay. So notice when I come back here, if I hover over increment by 3, it is a func of an int and an int. But the way it's going to work is it's always going to pass in a 3 to start. But that same apply function is also used for multiply. And the reason is because those two function signatures are exactly the same. 2 ints coming in and an int coming out. So there was no reason for me to generate another method to do that. Okay. What the method that is being passed into me does is immaterial. I don't care. I'm just invoking it. So in the case here, that's going to be calling the add underneath the scenes. This is going to be calling the multiply. Okay. And yeah, I see questions here. I'll come back to them in a moment. This apply with optionals, this gets back to that thing about having optional values with defaults, is that I can generate a delegate on the fly that will match what the original signature was and what the partially applied signature should be. And that's what you see being passed in here and being returned. Okay. To the user, unless you hover over this and you say, what in the heck is apply 42 delegate? That's just a naming convention I came up with. If you just kind of ignore that and just use this library this way, you get partial function application with functions that take optional arguments. So I found that to be pretty cool that you can do. Okay, let me answer some questions here. What about Korean DSLs? Yep, I'll talk about it at the end. I'm not going to show an example, but I will talk about that rather quickly. You can do it. This is a long story. If generated code is not saved on drive, but where is it in memory? I think it's technically squirreled away somewhere on your drive temporarily. I'm not exactly sure about that. There was a discussion or an interview with the C# folks. They're talking about that debugging experience I mentioned before. And when you create a PDB, what they're doing is they're actually taking that source code, putting it somehow in the PDB along with all the sequence points and how it matches up. So when you step into it, it just basically loads that as a C# file and puts the breakpoint in and where you break and everything just works. Okay. How that works, I don't know. To me, it's a little bit magic, but all I know is that it actually does work. Can they use the generate non-C#? Okay, so can you essentially generate non-C# files? Not now, but that feature has been requested by a lot of people. And I think it might, or at least it's definitely on the radar, and it might show up in C#10, where you might be able to say, not only do I want to create a C# file, but I want to create a proto file. I want to create a JSON file, an XML file, whatever you want. And that would be part of the source generation process. So not yet, but that is something that's being discussed. Yeah. Generating code from a template is a powerful tool. Yeah. And because it sometimes get asked about which ideas if you rework a template, sorry. Yeah. This reminds me that sometimes I always get the question about T4. What about T4? Can I use T4 here? No. Yeah, that's not an option. And that doesn't mean T4 is dead. It still works, but I would really be looking at using source generators because it is part and parcel. It is fully integrated with the compiler. And so the experience is so much better, in my opinion, than using like a T4 template generator. Okay, so just wanted to mention that. Can I look at non-C# files as I generate? Yes, you can. That was the thing I talked about before with additional files. So if I'm trying to think, do I actually do that in any of my generators? I'm not sure. I don't remember off the top of my head if one of those actually takes an additional file. I think one of them does. But yeah, look up additional files, which is just something that you can specify in a CSproj file. And then if I go back here to inline mapping and I go to just the generator itself, and I say, I can always tell when it doesn't have the same scrolling thing. If I go to context.additional files, okay, And so those will just magically be passed into you, into your source generator. Yeah, there's another source generator I've created. Now I just remember which one it is, and that's where I've done it. So you can do that, and then you can examine the contents from that file if you want to. Okay. All right, the last one I want to show is something that I created about 6 years ago called Rocks. It's a mocking library, very similar to MOQ or NSubstitute. Those libraries are awesome, and I use them extensively on projects I've been on. So again, this isn't to replace it, but MOQ and Substitute underneath the scenes, they've always used some form of IL generation to create the mock on the fly. If you don't know what mocking is, it's basically a way to say my code under test has a dependency. I don't want to actually call the real dependency in my test, so I create a mock with some expectations on how the code should actually be used. I run my code and make sure all my expectations work. Some people like this, some people don't. I'm not here to argue whether mocking is a good or bad thing. I think there's some definitely merit to it. I can see where it's also overused, and I've probably overused it myself a little bit on projects. I will admit that. Okay. But what I wanted to do with Rocks is create a mocking library where what I'm generating is C# code on the fly, because it was still runtime at the time. But then if I wanted to debug into it or see what it was actually generated, it was all C# code. Much easier to do. Well, with source generators coming out, I decided to rewrite it all so that's actually doing source generators, but also do it in a way so that the generated code is, you may find it friendlier, you may not, but it's definitely different. And so I want to show you what this does. Okay. So this would typically be in a unit testing project, but I have a console app here, so the host doesn't matter. It's going to work the same way either way. But let's look at this code down here first. I have a record that defines a customer. I have a repository where I've got a way to get an ID and retrieve a customer and delete a customer. Yeah. I also have this, you could call this a customer service if you really wanted to, where it's going to use that repository. And when somebody calls get, it's actually going to turn to the repository and retrieve it. Don't focus too hard on what this is actually doing or should you use a repository or not. That's not the point. The point is that I have code that is using some kind of dependency. And rather than passing in the real implementation of my customer repository that is going to be configured at, runtime and production, I want to write a test that talks to something in memory. Okay. So keep in mind that the one thing I'm going to use is retrieve, and I'm going to pass in that same ID that's given to me in get. Okay. So I have no idea what that emoticon is, Thomas. Is that a microscope? I think so. I can't tell. So if I go back up to my demo here, I've got my ID, got a new customer. That's what I'm expecting to be returned to me. And now I use my rock library. Okay. So I have a rock.create and I pass in that type. Start looking at what's actually given to me here. So this is where you set up all your expectations. For example, let's comment this one out for now. But for example, I know that the code under test is going to call retrieve, and it's going to expect that I got an ID value passed to me. Okay. So my source generator is actually going to look at the thing that you pass in as a generic. And when I say rock dot, and I zoom in here, you're going to see I have an instance, a methods, and a properties extension method. Okay. So I look at all the things that you could potentially set up expectations on, and I essentially group them together like this. The instance extension method allows me to create an instance of the actual mock object. And these other two are just to say, I want to set up expectations, either methods or properties. So it's basically just a way to, not have everything right here at the dot and separate it out a little bit more. Okay. So if I branch back out, I have methods. And now if I say dot here, you'll see that I have a retrieve method. Okay. This is setting up an expectation, and I'll F12 into this in just a moment, but this is setting up an expectation to say code under test should have retrieve called, passing in that ID. I also need to return that customer object. So that's what I'm going to do here. Of course, it's all type safe. So if you look hard at this code, you will see that if I go this, you'll see that's what's actually being passed back is a customer. Okay. That's what I'm expecting to return back. If I was going to call this multiple times, I could say call count, not call back, but I could say call count of 3, and that would work. Okay. If I wanted to call back to do something while that method was being executed, I could provide a callback. In this case, it'll be getting an int and returning a customer. I could do that as well. Okay. So that's the only expectation I need. So I need to create an instance of that mock, which is done here. And if the thing passed into me was an abstract class that had a constructor with multiple values, the generated method would actually allow you to pass those in here as well. In our case, it's just an interface, so we don't have that. I'm going to pass that mock into my retriever. I'm going to call get, and then I'm going to print out what that retrieved customer looks like. And it should be a customer with an ID of 3, name of Jason, and an age of 29. I'm also going to call rock verify because I'm going to verify that all my expectations were met with the code under test. So if I run it now, what I should see is just a customer printed out to the command line. And I do. Okay. All the verifications, all the expectations, everything matched. So we're good. What happens if I said here that I actually expect to get 4, not 3, or I expected to get 3, but what I actually passed in was 4. Well, now I'm going to get an exception because that wasn't what the expectation was. So this is actually good because something didn't happen right in my code under test. Okay. Or I can come back up here and say, you know what, I'm going to add an expectation that the ID getter property should be called and it's going to return that ID value. But as you saw at the code under test, it doesn't call this property. So when I run it now, I actually get a verification exception because this is basically saying you set up an expectation and it wasn't met, it wasn't called. Okay. So that's what this library does. And if I F12 in an instance, I'm not going to go through all this, but this is all the generated code, all those methods, property extension methods, the getter extension method. Here is the instance extension method that actually creates an instance of this class I generate. That's my mock type. You can see here, I have retrieve, delete, I have the ID property, and they all have a bunch of implementations in here to see if what you're calling matches any expectations that you've set up. And it also increments call counts and it will return values as you have it set up. All that's done through rocks. Now, as you can imagine, this isn't easy. This took quite a long time to get this to work and produce code correctly. Okay. And some of these names start getting quite long and they're maybe really hard to look at the signatures of everything. But you as a consumer of the rocks library, you're probably not going to do that. You could F12 into it, but you're just using what the library is giving to you. That's the value add. Okay. And all this is documented so people can see how this all works. So I find this, not because I think I did something powerful, but it's the source generator concept that allows me to create something like this. And I can let you do something like this as well. Yeah. All right, so let me finish up with my presentation, which is the call to action. The thing I want everybody in this call to think about is what can you do in your code that may actually work better as a source generator? Maybe you're not in C#9 just yet, or .NET 5, okay? That's okay. Even if you're not, hopefully I've started getting some gears turning in your head and saying, this might be something that we could really get a lot of value out of with source generators. In terms of some other examples, people have actually, yes, there's an example from Microsoft in creating a DSL with this. You can generate serialization paths that are much faster. There's a library called Strong Inject, which is a type-safe compiler, well, at compile time enforced IOC library. So if you've done dependency injection and use IOC, you can set it all up and it all works well, but you may not know until runtime if something did or didn't work. This library checks everything at compile time. Quite an interesting idea. The Blazor routes one, I found this to be so kind of innovative. It's not huge, but it's just, oh, I never even thought of that kind of idea. So this guy named Andrew Locke basically said, well, in a Blazor app, your Razor code gets compiled into C# code, and then that gets compiled into IL, into your assembly. And if you put a page directive in your Blazor component, I think that's the right component, the name of the directive. I think I got that right. But that turns into a route attribute. And that basically says this component can be routed to if you put this into your URL. So what he did is he looks at compile time and says, for all the components that exist in this application, which ones have route attributes? And for those that do, what's the format? What's the shape of that route? And so what you can get is a nice type safe compiled version of your routes, and you could use that to create almost like a Swagger page to your Blazor app and say, these are all the valid things that you could type in for this app, and it will just route to that and work. Okay. I thought that was a really cool idea. And you may have some other ones that come up from what you're doing. It'd be interesting to see what people do in the future. So that's all I have for tonight. Hopefully this has been interesting and informative. I'll be here to answer any questions that people have afterwards. Totally open to that. So I am done for the evening. And thank you all for attending. I appreciate it.
Yeah, thanks, Jason. This was awesome talk. Anyone else have any questions? Yeah, you feel free to come off mute. I think we're done with the talk. So
I do have a question about cancellation.
Mm-hmm.
So in the execution context, you have a cancellation token. How would you go about invoking that?
Yeah, so cancellation token, throw if cancellation across it. So this is something that has been there with analyzers as well, and also refactorings. If you've ever created one of those, you're getting a cancellation token given to you, because then that allows you to look at the cancellation token, and if you've been asked to stop, then you can just stop. And the way to do it, at least this is what I've been told, is you just go into the cancellation token and just occasionally call this method. So if the cancellation token has been signaled, then what you're going to do is call this method, which throws an exception, but it's the right thing to do. Now, how often you do this is a little subjective. Do you call this at every point in your code? That would probably, actually start adding in a little bit more work than needed. So, but this is a way for you to say, if for whatever reason, the tool that I'm using, like Visual Studio, it's determining that you got to stop doing what you're doing, so stop it. But it can't really force you to do it. So you really should at some point consider calling this method and saying, okay, well, if I wasn't able to get it done in time now, then I'll essentially stop. Okay. I would imagine if you're actually in a true compilation phase where an assembly is going to get written out to disk, that the generator is probably going to be, I don't know, I'd actually have to look at the source code for Roslyn. I would imagine it probably is given a little bit more leeway in that case to get stuff done. But yeah, so I don't know if that answers your question, but that's the one thing you want to keep in mind is you do have a way to say, be a little bit more responsive and reactive to the user experience and cancel what you're doing if it's taking too much time.
Okay, great, thanks.
Yep. I'm glad people enjoyed the talk, so thank you for those comments. I appreciate it.
So I've got a question.
Sure.
The thing that comes to mind, and I'm kind of still effectively in my second year with C#, so this may be a stupid question, but
there are no stupid questions. Honestly,
I
really want to say that there are never stupid questions.
So,
there are only stupid answers, which I might give you one. So
one of the things that I've learned as I've been getting into C# is the typical like IOC container configuration files don't have IntelliSense for obvious reasons. You're typically, when you want to do something that's not compiled for configuration, you're typically, as far as I understand it, and I may be missing something, passing in a string that matches whatever the property you want to actually access in the configuration file is. And one of my ideas was, well, I'd really love to be able to just add a property in XML or JSON in the configuration file and get that IntelliSense. And this feels like it could do that very easily.
So you said IOC, so are you referring to inversion of control?
Just like, you know, the typical container builder that you've got the configuration file stored however you've set it up, be it JSON or XML or whatever.
So you're actually, are you using like structure map? There's one of the ILC containers actually you can set it, you can set everything up in code, which is what I highly recommend people do, or you can set it up in a configuration file. Is that how you're doing it?
This is something I was looking into. This is something I'm looking at options to implement.
Okay.
I know there's just a standard container builder and like the ASP.NET template that comes with Visual Studio.
Yeah. So yeah, first thing is you can, I would recommend you do it just in code itself. But if let me see if I phrase the question this way, if it's what you're asking. Could I make a JSON file that basically allows me to specify how a container should be set up? In other words, I look at the JSON file and that tells me how that container should be built, and I'll write out the C# code to actually do that.
This is more of just the configuration aspect. So what I was thinking was, if you have your configuration file with all your settings, it would be nice to be able to like add a node or some such in that configuration file, and then get that accessible through IntelliSense, so that as you go to actually access whatever that is storing for a value, you had IntelliSense and you weren't just kind of blindly typing in the dark.
Okay. This is unfortunate where a virtual meeting gets a little
a stupid question, like I said.
No, it's not stupid. It's just, it's one of these things that, again, because if I was there, we could potentially go out and have a beer later and then talk about this, and
I
like
can
actually
appreciate that.
you know, that'd be a little bit easier. If I understand the question the way I think I do, there is, you can, again, you can look at additional files and see the contents in there. The example that comes to mind that I think might match what you're looking for, it's not IOC specific, but I think it's kind of what you're looking for, is there's an example from Microsoft where they read a CSV file as an additional file, and then they end up creating a type-safe API around the CSV file. So it basically looks at what the CSV is, like the first line is the headers and then all the data is underneath it. And it just does some analysis to say, if those values look like ints, then I'm going to assume that that first column that's an ID is an int. And so it basically puts a whole wrapper around the CSV as C# code, so that you start getting IntelliSense around that CSV file in a way.
Yeah, that's exactly what I was looking
to
do.
So look at my my notes on that last slide in my presentation. One of those points to that example. But if you, in fact, let me just see if the search gods are with me tonight. If I say C# source generators, CSV, let's see if it actually, yeah, there it is. So CSV generator usage. So they include like this people file and cars file. And that's what the CSV file, let me zoom in a little bit on this. That's what the, no, my God, not that much. Okay. That's what the CSV file looks like. And then you can end up doing like using CSV, and they get cars.all.toList for each, and the brand and the model and the year. And, this basically just generates everything for you. So this might be something to look at, and that's what you can apply in your case.
That's probably going to be the first thing I play with. This is really cool.
I just put that in the chat. So
thank you.
Yep. Any other questions?
Yeah, there's a question in chat. What version of .NET has container template?
What version have done it as container template? I'm not sure I understand what you mean by container template. Yeah, I'd answer the question. I just don't know what that means.
I
So.
think he might be talking about what we were talking about, the Microsoft's IOC container. That's an old thing as far as I know, but I'm not super familiar on when they introduced that.
Okay. All right.
So I have a question. This only comes with C#9, right? And C#9 also, if I understand, if I remember correctly, C#9 also introduced records.
Yep.
And will this work with records, or what's the?
Absolutely. So if you were looking, so if you wanted to generate a record, that's easy. I mean, because you would just make a string that said, public record customer, and there your record definition is. So that's easy. If you wanted to react to the existence of a record in a source generator, that would work just fine. Just to show this real quick, if I come here and I say like, well, no, I can just come down here because I already have a record defined. Customer, let's bring up that syntax visualizer. And I believe it's going to be a record declaration syntax. Yes, I did get that right. And so that's the syntax node type for a record. So yeah, you could, in your source generator, if you're looking for something on a record, you would just have to say, hey, I'm looking for a record declaration syntax, and then do what you need with it from that point.
Cool, thanks.
Yep. So I'm going to look at what Thomas just posted here. Build an IOC container. Yeah, service provider, service collection, classes, application builder, context. Okay. I'm still not sure what the container template is itself.
I misheard the container template part. Yeah, I was just curious about what a container is in general.
Oh, okay. A container is just something that basically contains all of your registered dependencies. So for example, the thing I did before, I had an iCustomer repository. So if I go look at that code, come back here, this retriever is taking an instance of that in the constructor, but it's an interface, it's not an implementation. So something at runtime actually has to pass in a valid object that implements this interface so that this call here is going to work. And so that's where the IOC part comes in. It's this container that just says, if I need to make an object of type customer retriever, I'll see that the constructor is that needs something that implements this interface. So somebody should have registered before the app got running something that says configure the container to say, when somebody asks for this interface, give it an instance of customer repository, which may be a class that implements this interface. And so for me in this code, it's immaterial. I don't care who implements this, but that also gives me the flexibility that in a test, I can test against a mock. I could potentially test against one class in beta and then another implementation in our production environment. And all that would mean is just a switch in how the container is set up, which is like an ASP.NET Core is typically done in startup.cs. Okay, so dependency injection and version of control is basically the concepts that if you want to know what that is, there's a great book by Mark Seaman on SEEMAN on dependency injection. I think there's a new edition of it out. Highly recommend take a look at that if you are more interested.
Yeah, I got the job interview question regarding what is dependency injection, I think it was. And it sounds like, yeah, it's something in in .NET Core, something you register some services that have interfaces, and then you can create a class and you can just declare parameters in constructors, like in a class library that's not, you know, it doesn't know nothing about startup, and you can start and those classes that were registered in startup, they will be injected into the constructor or supported by a constructor, and you can use them in a class outside
Yep.
the application.
Yeah, that's, I mean, I actually have a talk on dependency injection and everything, you know, that goes along with it, because it's a topic unto itself. But long and short of it, you know, that's what it is. So,
Yeah, it's a little bit off topic. Sorry about that.
no, that's no, that's okay. That's okay. All right. Anything else? This is good. I've had user groups this year that nobody asks questions, so I'm enjoying this.
Yeah, we are special.
Silence is golden in a way. Again, if something comes up later, if you try to do any of this stuff and you get lost or confused, you know, again, send me an email, and I'd be happy to help out. You know, help out with anything that comes up in the future.
Excellent. I'm gonna stop recording. People can hang around and chat if you want to.
Mm-hmm.